Today we are going to do section 5.7, which is about inverse functions and a sort of a repeat of section 3.7. So we're going to go through this section fairly fast, and I ask you to do most of the examples by yourself with the help of the book, and you should be able to do most of it while I just go over it briefly. Now, so first let's look at example 1 on page 511. Okay, we have this. This is basically an identical problem where you have the function f, and then you have the inverse, and you have the proof that when you stuff one into the other, it comes out to be the same. That is, specifically, the meaning of the inverse function is when you calculate a function, okay, and then you do the inverse, you get back where you started. That is, you start at x, right, and you become f of x, and then when you put that in the inverse function, you go back to being x again. And that's true either direction. That is, whether you start with f or the inverse of f. The f -1, that means the inverse function. Now, to show some two functions are inverses is you pretend that for example, in this case, okay, we'll put f of x in the inverse. How do you do that? So the entire f of x, which is 1 over x plus 1, will be put in the place of x. That is, 1 over x plus 1 will become the new x, okay, right here, see? 1 over, the new x is 1 over x plus 1 minus 1. And don't forget how to do this kind of fraction, okay? Now remember this, managing fractions was covered in I believe the end of chapter 1, and as always, you must know chapter 1 really well, and which includes how to handle fractions of this kind. And as you can see, to handle this fraction, to divide by something is you invert and multiply. When you divide by a fraction, in this case 1 is being divided by 1 over x plus 1, you invert and multiply it, which turned it into just x plus 1, and so on. So please do the example 1 by yourself as part of your homework. I won't be assigning any actual homework from the homework section, being that this is a bit of a review, okay? So, but it's still good to make sure that you know how to divide by fractions, okay? That is a problem that many students seem to forget quickly. And so if you do forget it, please look it up. You know, even if you have to look it up 100 times, there's nothing wrong with that. Just look it up if you can't remember these very important skills. Now, next, example 2. How do you find the inverse of a cubic function? It doesn't really matter. What you're doing here is you're isolating x. That is, here's our cubic function. I am right now, what is this? This is example 2, okay, on the following page. And anyway, so we have a function, f of x equal to 5x cubed plus 1. So you let f of x be y, okay? That's how we do inverses. And then we're going to pull x out of there such that the equation becomes x equal to that, did they really change that? Okay, let's see. They actually reverse the position of y and x. I suppose that is really not necessary. I guess I will just do this myself, okay, instead of depending on the book. So what we're going to do, our function is f of x, which is y, okay, this is example 2. Now, f of x equal to, or y equal to 5x cubed plus 1. To calculate the inverse, we need to isolate x, that is, kick everything else onto away from x, so that there's only x left. So to do that, first we'll get rid of the 1, what becomes y minus 1. And then, okay, and then, so this side becomes 5x cubed. This is the same thing we solve regular equations. And then, so the next step is we divide by 5, okay, and then y minus 1 divided by 5 is going to be equal to x cubed. Okay, and we need x, okay, not x cubed, so we'll take the cubic root of both sides to cancel it out. So once you take the cubic root, and then this becomes just x, and whereas that thing, we'll take the cubic root of it. Because you always do the same thing to both sides of the equation, so that is fair. Okay, so 1/3, okay, that's the cubic root, and that is the answer. That is the inverse function. And the book wants you to exchange x and y, which I think that makes it really confusing. I mean, why bother exchanging it? Here, this is the inverse function. The inverse function, its independent variable is y, that's all. And you can write it as this way. That is, you can change the name of the independent function to be x, like what your book has, right? In reality, whether it's y, x, it makes no difference at all. It's just a name for the input, okay? You can call it y, call it x, call it anything you want. And that is, but anyway, that is how to do example 2. And also remember from section 3.7, if you don't remember, doesn't matter, we're mentioning that right now, is that the inverse function and the original function it has a situation where the graph is opposite. In the sense, that is, what used to be 0, 0, 1 is now 1, 0. And in other words, the graph is a mirror image across the y equal to x line. That is, if you imagine y equal to x is the mirror, then the inverse function is the exact flip, the mirror image of the other one. So I guess in order to plot the graph and make sense, then I suppose you should change the name, that change this name to x, so that you're plotting on the same graph. That way this situation actually makes sense. But to solve the equation, you don't have to change it yet. So I suppose what I recommend is once you're done with the solution, then you can change this. So then rename this thing as the inverse function then, f inverse of x, we'll call it x minus 1 over 5. That is, you change the y back into x, because now is so that you're consistent, and I mean not consistent, so that you can plot both things on the same graph. Otherwise, that thing will be in terms of y. Anyway, that is how you come up with inverse functions. You just yank it out from, like pulling a shirt inside out. You yank whatever's in here, and then that will be the other situation here. So the inverse function is always the mirror image of the original function across the slanted line, at the diagonal line, okay, the line that's 45 degrees, and the inverse function is always the mirror image of it. So that is example 2. So please do that as part of your homework. Okay. Next, let's look at example 3. We have calculating the inverse function of sum of x minus 4 squared. The solution is the same. What you do, I guess your book wants you to exchange x and y. I guess that's okay. You might as well exchange it, I suppose. Although I don't normally bother with exchanging. So but when you end up graphing it in the same graph, then you do have to exchange it to make sense. The inverse function is then you pull it out. Okay, that is, you solve for. Once you do the exchange, once you do so, here's the original function. Is that the original function? Yeah, I think so. I think then here's the exchange. And then you have to take the square root and then solve y in terms of x. And that is about it. Now the inverse function usually has a restricted domain. In this example, as you notice, when you take the square root, you will have the positive and the negative root. That's because the inverse function has to be restricted in the domain, because you have to pick one. Okay, is it positive or negative? A function cannot have end up with two values. That's not the definition of a function. A function by definition has just one value, so you need to pick one. Usually they tell you which one to pick, or if they don't, then in this case we usually pick the positive one. So y equals the square root of x, and then plus 4 will be the inverse of the original function. And so please do that yourself as part of your homework. So sometimes a function you will have more than one option for the inverse, and that depends on that really depends on the situation. Like, how do you want the function to be inversed? Do you want it to be the positive one or the negative one? And because either one is possible. Okay, but you have to pick one for the inverse function. It cannot have both. So that's example 3. Next. Example 4 is a similar situation. You just you need to all right, and you have to go through the process, which give you a plus and minus option, and then depending on the situation, you might choose the plus one or the minus one as the inverse function right here. So please do this as part of your homework. Okay, I guess we will just follow what the book says. You can exchange. The first step to doing inverse function is exchange x and y. That's just so that you can plot it later, and then yeah. And then once you've done that, then you need to isolate the new y, okay? Because being the y and x exchange position, exchange rows. So then y is now the y. Well, who's the new y? I don't even know. Anyway, so the point is you need to solve for y in that case, which quickly comes out. And in this case, there are 2 options, and you have to settle for one depending on what is required in the situation. So please do example 4, and yeah, let's see, what's this? Right, so here's the graph. On the next page, I'm on page of 515. There is a graph of how the inverse function is being inversed. As you can see, the graph shows that the inverse function, we can only have either the plus or minus one, so we'll keep the plus one, okay? So you notice that the f of x, which is a parabola, used to have 2 parts of the parabola, but being that we have to calculate, we'll ignore the negative part, okay? And then only do the inverse of the positive part, which gives you the red line. As you can see, the red line is the mirror image of the blue line. The dotted line of the parabola is the part that we're ignoring. And we ignore it by restricting the domain. That is, we don't care about that part of the graph. And because we need an inverse, and the inverse has to be unique. Yeah, so please do that as part of your homework. And then next, let's look at example 6. Example 6 has, let's see. Yeah, well, anyway, here is some kind of cone, okay? And then the volume is given as this thing. Generally speaking, the volume of a cone is 1/3 pi r h. 1/3 pi r squared. That's the base of the cone, base area times h. That's the height of the cone. So please memorize this. Okay, this actually should be memorized. So write that down in your notes, in your cheat sheet or something. And so this is the radius r, and this is the height of the cone is h. So the formula of a cone should be memorized, because we do use it quite often. Let's see. So in this case, why is that different? It's because it specifies that h equals 2r. Okay, specifically h is 2r, which means so then you replace h as 2r, then it becomes pi. There's a 2 here. Okay, then it becomes 2 and pi r cubed, as it shows in the book. Anyway, well, whatever it is, you need to now isolate r in terms of v. All right, so well, that shouldn't be too hard. Actually, I think, let me see. Sure. Okay, I'll just do that here. Being that is, okay, so the volume is equal to, I'll stand on this side. So volume is equal to 1/3 2 pi r squared times r, which is r cubed, okay? And because h is 2r in this situation, so then we need to isolate r. So let's get rid of every single thing that isn't r. First, we'll get rid of this thing by multiplying both sides by 3. That'll cancel it out, okay? Or move this thing across the equal sign up, okay? And right. Anyway, these numbers will move it across the equal sign down below the division line. So that move 2 pi down here. And this is also called cross multiplying. So that gives us r cubed. And eventually we get r equals to the cubic root. I'm not going to write the cubic root. We'll just write 1/3. Okay, so remember the 1/3 power is the same as the cubic root. So 3v over 2 pi, and then we have 1/3 here, and that is equal to r. And notice that in this case, the book didn't tell you to exchange r with v, because that wouldn't make any sense at all. In this case, r is r, then it can be represented by v this way. So that if you have a specific v, like I don't know, 100 cubic meters or something, or cubic feet, then you can do this math, take the cubic root, and then you know what the radius of your cone is going to be. So that is the point of this. Let's see. Yeah, I think that's about it. Right. Oh, wow. They did say that. They said, what happens when v is equal to 100? And then you have to, let's calculate it. Okay, so please pull out your calculator and type this in. V equals 100. What would r be? All right, so I typed this thing into my calculator. This is something good for you to do. This might not be as easy as it looks, and a lot of students might make a mistake in the typing and then can't get the right answer and don't know why. So v is 100, okay, and all the other numbers are pretty clear. But when you type it, here is what you do. See, first you have 3 times. Let's see. Let me move somewhere. Yeah. Okay. That should be okay. Right. So first we have 3 times v. That's good, right? And then divided by 2 pi. Now the divided by 2 pi, the 2 pi need to be in parentheses. If you don't have that, then you're going to have a problem. Okay. And then, right. And how to type pi in there? In my calculator, there's a pi right here. Okay, I had to push the shift button to get there. Now please check out your own calculator to see how to type pi. Some calculators just have it right there. Okay, you don't have to push anything special. And so anyway, so please type pi in there. Your book says just use 3.14 as pi. I mean, who does that? Nobody. Okay, let's pull out the pi from the calculator. And so anyway, well, you can use 3.14 if you absolutely don't know how to get the pi into the calculator. Then the 3.14 is better than nothing. Anyway, so if possible, please dig pi out in your calculator, okay? And then you have the close parentheses. The parentheses is around the 2 pi, so you're making sure that you're dividing by 2 and pi. If you don't do that, it will divide by 2 but multiply by pi, and your answer will be weird. Well, wrong. Not just weird, but wrong. So once you do the division, we'll write the close parentheses. That's for the 2 pi. And then another close parentheses, okay, that's for, and the second close parentheses is for the 1/3 power, which we started with. So this whole thing has to be in parentheses because the whole thing is being taken to a 1/3 power, okay? And then I have the whole thing raised, okay? Let me move over a little bit. Okay, raised to 1/3 power, which is raised to parentheses again. It's always good to put more parentheses in if you're not sure what it's gonna do. So we're raising the power 1 divided by 3. Okay, then close parentheses. Then yeah, everything should be good. Let's push equal. Okay, it gave me an answer. Let's see what the book says. 3.63. Yep, that is right. That is what the book says. As you can see, the book says to use 3.14, and it did come out with a very similar answer, which is okay, like I said. But if you could, please use the actual pi in the calculator, which is recorded to, I don't know, 9 decimal places, which is much cooler than use 3.14. I mean, what is this, 5th grade? When we don't use 5th 3.14, okay? And anyway, so anyway, but of course, if 3.14 is still not that terrible, okay? Yeah. Anyway, in fact, if you can't get the pi to come out, it would be better if you use a little more decimal points, such as 3.1416, for example. That's in reality, that's good enough, okay? And but anyway, that is it for this problem. So next, let's look at the next thing. So be sure that you do the calculator practice. It sounds like, well, who doesn't know how to punch the calculator? Trust me, a lot of people don't. Because they miss the parentheses, or they just don't know how to get the pi to come out, or even know that how to type in the cubic root. Okay, please get this and make absolutely sure that you can get it out, to get it to come out. If you have any trouble with calculator, please dig deeper, like look online, look at your calculator manual, look somewhere. You absolutely must know how to punch this answer out in the calculator, all right? There is no excuse to not know how to do it. Anyway, so next, we're gonna skip example 7 because it involves deciding where rational functions are positive and negative, which I don't think you need to do that right now, and it's tedious, and you will be doing plenty of it, I guarantee you, in the future. So we're gonna skip that and focus on focus on inverse functions. And then finally, example 8, we have a formula. Okay, example 8 is we are given some formula C in terms of n. Never mind what they are. The point is we need to isolate n in terms of C. Again, you notice the book doesn't tell you to what, exchange n and C? No, of course not. That would be ridiculous. So once we know that C is like this for n, you beat around the bush a bit, okay, and then try to pull n out by multiplying by both sides, the 100 plus n, and then mess around with the numbers a bit until you come up with this. Okay, that is round up n on one side, all right, and then get rid of everything that isn't n and put it on the other side. Yeah, so please study this carefully and figure out how to do it yourself. All right, and then the book wants to know what happens when C is 0.35. What is the value of n? Okay, I think I will do that. So please do this on your calculator as part of your calculator practice. Okay, so I will do that, and please do that yourself. All right, now I have it typed in. So first, let's look at what we're typing. The question, it doesn't sound that hard. The first trick is you got to put the numerator in parentheses. Why? Because there's a minus there. There's a minus 20, and if you don't put it in parentheses, then only the 20 will be dividing. Okay, the other 100 times 0.35 is not going to do any dividing at all. So then your answer is not going to be correct. So then once we do the dividing, notice the next thing I do is the entire denominator is I put it inside. I put it in parentheses as well. Why? Because there's a subtraction there. If there's a subtraction there, and you have to put stuff in parentheses. Otherwise, the division symbol here will only divide by 0.4. It will not divide by the next part, and then you're gonna have a mess. Okay, well, you're not gonna get the right answer. So then once you have, so basically the trick is that both the numerator and denominator should be put in parentheses because there is a minus in the numerator and a minus in the denominator. Okay, so then, but once you've done that, then everything should be okay. So let me push the equal sign to see if I got it right. 300, yeah, that is correct, yes. So when it comes to calculators, you have to be very clear on what we're doing, okay? The calculator will do multiplication and division before minus and subtract. Before minus and plus, which means there are times that you will need to put in parentheses, especially when it comes to fractions. In general, just put in parentheses if you're not sure, okay, so that the calculator doesn't do things to subtract something else, or do it in the wrong direction, or miss dividing part of it, and then your problem is wrong for no reason. No good reason. So that's that. So next, So please do this yourself, okay? That's example 8, and I believe that is the end of this section. So for this section, being that this is a bit of a review for inverse functions, I will not assign any homework. So please simply do the examples, except example 7. Please skip that, and we'll be doing plenty of that later. So so do the examples, and then we'll move on.